Welcome to Automotive Channel, your go-to hub for decoding the machines that move us. Today, we're diving into the electrifying world of electric vehicles. Not just the cars, but the brains, the brawn, and the brilliance behind them. What is an electric vehicle, EV? An electric vehicle is a vehicle that runs on electric energy stored in batteries instead of fuel, petrol, or diesel. This electricity powers an electric motor, which drives the wheels. Basic principle. Unlike conventional vehicles, internal combustion engines, EVs do not burn fuel. They use stored electrical energy to create rotational motion. Major components of an electric vehicle. Component function analogy. In petrol car, battery pack stores electrical energy, DC power. Fuel tank battery management system, BMS, monitors and controls battery health, charging, and discharging. Fuel system control electric motor converts electrical energy to mechanical energy. Engine motor controller inverter controls the speed and torque of the motor by converting DC from battery to AC from motor. Engine control unit ECU. Battery pack. Type. Mostly lithium-ion or lithium iron phosphate LFP. Voltage. Typically 300 to 800 V in modern EVs. Capacity, measured in kWh, kilowatt-hours, indicates how much energy is stored. Example, a 60 kilowatt-hours battery can theoretically deliver 60 kilowatts of power for 1 hour. Key parameters: energy density, energy stored per unit mass. Cycle life, number of charge-discharge cycles before degradation. State of charge, SOC percentage of battery energy remaining. Electric motor. Common motor types. BLDC, brushless DC motor. Compact. Efficient, used in e-scooters. PMSM, permanent magnet synchronous motor. High efficiency, smooth control. Used in Tesla, Hyundai, etc. Induction motor, IM, robust. Used in Tesla Model S X. How it works. Electric current creates a rotating magnetic field, which causes the rotor to spin, turning electrical energy into mechanical rotation. Controller inverter. The controller decides how much power to send to the motor, how much torque to produce, when to reverse current for regenerative braking. It acts like the brain of the drivetrain. Wiring harness. Function. The wiring harness is a network of electrical cables and connectors that carries high voltage, battery to motor. Carries low voltage, sensors, signals, communication. Provides grounding and protection. Types. High voltage cables. Orange color for safety, motor, inverter, battery. Low voltage harness. Sensors, BMS, ECU, lights, infotainment, etc. Torque, power, and speed in EVs. Term meaning formula concept. Torque, T. Rotational force produced by motor, Nm. Power, P. Rate of doing work, Kw. Where omega is equal to angular speed in rad s, speed how fast the vehicle moves, kilometer h. Related to motor RPM and gear ratio. Relationship. EVs produce maximum torque at 0 RPM, instant acceleration. Power increases with speed up to a limit. After a certain RPM, torque drops but speed continues to rise. Regenerative braking. When you press the brake pedal, the motor acts as a generator, converts kinetic energy electrical energy, charges the battery, improves efficiency. Cooling system. Maintains safe temperatures for battery, motor, inverter. Types. Air cooling. Simple, less effective. Liquid cooling. Used in modern EVs for efficient heat management. Transmission. Most EVs use a single-speed gearbox because electric motors can produce usable torque over a wide RPM range. No need for multiple gears. Performance metrics. Parameter typical value example. Voltage 350 800 V Tesla Model 3. tilde 400 V power 100 to 400 kW varies with model torque 200 to 1000 Nm depends on motor type efficiency 85-95% much higher than ICE range 200 to 600 km depends on battery capacity charging time 30 minutes 8 hours DC fast versus AC slow. Electric vehicles aren't just a shift in propulsion, they're a revolution in how we think about mobility. From the instant torque at 0 RPM to regenerative braking that recycles energy, every component in an EV is designed for efficiency, simplicity, and sustainability. With fewer moving parts, smarter control systems, and high-voltage architecture, EVs offer higher efficiency than traditional internal combustion engines, lower maintenance thanks to simplified transmission and drivetrain, cleaner energy use with potential for renewable integration.
Thanks for watching. Stay tuned for more simple and clear automotive explanations, only on the Automotive Channel. If you enjoyed this video, don't forget to hit that like button, drop a comment below, and subscribe to stay updated. Your support helps us bring more helpful content your way. Until next time, drive safe and stay curious.